Ensoftec has developed a series of videos for the selection and design of stormwater facilities for land disturbance projects. In this video, I shall show you the design of micro-infiltration devices, like French drains, dry wells and paving blocks, using SWMSOFTVA. Virginia Department of Conservation and Recreation, or DCR specification number 8 gives a complete description of these facilities, their performance and criteria for design, their feasibility and design applications, regional and special case design adaptations, their construction and maintenance. The pictures and tables shown here are from these specifications. Table 8.1 gives the summary of stormwater functions provided by infiltration practices. You will notice that infiltration practices achieve a high degree of runoff volume reduction as well as nutrient removal. Hydrologic soil group areas A or B soils provide greatest recharge and infiltration rates. They are therefore considered as primary locations for infiltration practices. These devices are ideal to treat runoff from small and highly impervious sites. Table 8.2 gives the infiltration design guidelines. There are two levels of design, the baseline design, Level 1, or an enhanced design, Level 2. While a Level 1 design uses at least 2 forms of pre-treatment, a Level 2 design requires at least 3 forms of pre-treatment. The maximum impervious area that can be treated is 2,500 square feet. The bottom of dry wells and French drains should be at least 2 feet above the seasonally high groundwater table. I now open the project, which we had set up in video 3. BMP2 of outfall 4 is a French drain. I shall use this example to demonstrate the design steps. I go to File, Design BMP Facility. This opens the micro-infiltration. You will note that the required treatment volume and the percent impervious cover fields are already populated in the screen. The bottom of infiltration facility elevation is for bookkeeping only. Adequate pre-treatment is needed to prevent premature filter clogging and extend the life of the filter media. These basins are usually sized using the Camp-Hazen equation. Pre-treatment cells may be wet or dry. They must be sized to accommodate at least 25% of the total treatment volume, to keep sediment and vegetation out of the infiltration cell. If other acceptable pre-treatment practices, as given in Table 8.6 of the specifications are provided, I enter 0 in the length, width and depth fields of the pre-treatment cell. After entering all the open fields in the pre-treatment section, I click on the Design Pre-treatment button. The program calculates the required pre-treatment depth and area and compares with the size provided. The remarks will show if the pre-treatment design is satisfactory or not. If other acceptable pre-treatment practices are provided, I ignore the entry in remarks. The required design volume, which is the total treatment volume reduced by the pre-treatment volume, is automatically populated. You will notice that default values are provided for some of the fields that follow. In order to reduce the potential for nuisance conditions, the maximum drawdown time for infiltration practices should be 24 hours to 48 hours. A default value of 0.4 is provided for the porosity of the trench material. The time to fill the infiltration facility is usually 2 hours. The required surface basin surface area is computed using the Darcy's Law as derived by the City of Austin, Texas, Environmental and Conservation Services Department. The surface area is a function of the treatment volume, the infiltration rate, the infiltration depth and the time for water to fill the infiltration facility. With these input values, the program calculates the maximum allowable depth for the facility, using equation 8.1 of DCR specification 8. After entering all the open fields in the treatment section, I click on the Design Treatment button. The program calculates the required infiltration trench area, and compares it with the area provided. The remarks will show if the design is satisfactory or not. I go to the top menu bar and click on File, Save. This will save all the data including the results. I now go to the top menu bar and click on File, Print. The print report, which is in Excel format, gives the results of analysis. Micro-infiltration systems are generally located as offline facilities. Low-flow diversions or flow splitters in the form of a weir or curb opening, sized for the treatment volume, help minimize clogging and reduce the maintenance frequency. The program lets us design flow splitters. For this, I go to File, Flow Splitter Design. This opens the flow splitter bypass worksheet. You will notice that the water quality discharge and 10-year peak discharge are already populated in the form. I enter the bottom width of the concrete flume or the curb cut at the top and the length of bypass weir, to convey the 10-year flow. When I click on Compute, the program calculates the hydraulic head required to divert the water quality discharge to the facility and the hydraulic head required to divert the 10-year flow away from the facility. I enter the heights provided, and go to the top menu bar and click on File, Save. This will save all the data including results of analysis. I go to the top menu bar and click on File, Print. The print report, which is in Excel format, gives the results of analysis. This completes the design of micro-infiltration systems.